the electromagnetic spectrum. It can be hard to visualise this because the waves don't need a medium to travel through. So let's break this down to its components so we can understand things better. You're familiar with electric fields. Charged particles can exert a force on one another across a vacuum. Rub a balloon in your sweater and you can give it a static electrical charge which will attract small pieces of paper or even repel a stream of water. You may have seen a Van de Graaff generator which charges the strands of hair on your head, causing them to repel away from one another. Plus attracts minus, but plus repels plus. You're also familiar with magnetic fields. Magnetised particles can exert a force on one another across a vacuum. Magnets attract iron and a few other metals. They can attract or repel against themselves, and we can create electromagnets that we can turn on and off on demand to attract iron and other metals. North attracts south, but north repels north. So here's the strange thing. Electricity and magnetism are inseparable. An alternating electric field creates an alternating magnetic field, and an alternating magnetic field creates or induces an alternating electric field. This is how motors and generators work. We generate nearly all our electricity by spinning a coil of wire in a magnetic field. Both electrical and magnetic forces are non-contact forces, and so both can act without the need for particles. This means they can travel through a vacuum. Now I've said electricity and magnetism go together like bread and jam. So if we vibrate or oscillate one, we create the same vibrating or oscillating wave pattern in the other. This is an electromagnetic wave. It's an oscillating electrical field and its twin brother, the oscillating magnetic field, both travelling through space, because remember they can go through a vacuum. Now we know what an electromagnetic wave is, what can we use it for? Think about this. If we get an electric field and a magnetic field and vibrate them at just the right frequency, your eyes will actually detect the field and you'll see a red light. Speed this vibration up just a tiny bit and you'll see that light turn to green. Keep going and you'll see blue. Make them vibrate faster still and your eyes won't be able to detect them anymore. But the wave is still there, and we can use these higher frequency or higher energy waves for something different, like X-raying our bodies, or even higher energy waves, gamma radiation, to kill cancer cells. Slow those vibrations down again so your eyes pick up the blue light, then the green light, then the red light, and keep slowing them down some more until your eyes stop detecting the wave again. Then slow the wave down some more and you'll get infrared. This is a form of heat. Slow them down some more and we can use them to vibrate water molecules. This is how a microwave cooker works. Slow the vibration down even more and they become radio waves. So this is the EM, electromagnetic spectrum. All the different electromagnetic or EM waves laid out by their frequency or wavelength. Let's look at them by frequency first, as that's what we've discussed so far. Starting with the slowest oscillations, we have radio waves. Speeding the waves up a bit, and so giving them more energy, we get TV. Then microwaves and radar. Then back to infrared. Remember that one? That was a form of heat. Then as we keep speeding the waves up, we get visible light. Red first, and then as we vibrate them faster, onto blue. Think about being cold and turning blue. You shiver really fast. So blue is a higher frequency than red. Speed up the vibrations from here, we leave visible light and get to ultraviolet. This is the nasty stuff that comes from the sun. Now our waves have got pretty high energy and so they can damage our skin. Speed up the waves some more and giving it even more energy, it starts to get more and more harmful to us. Now we're at X-rays. We know we don't want to have too many X-rays in our life. Then finally onto the fastest and highest energy of them all, gamma rays. These are the ones given off during nuclear explosions. Remember though, high frequency waves, ones that vibrate quickly, have got short wavelengths. Low frequency, low energy waves have got long wavelengths. Be careful not to get them confused. Learn the EM spectrum by one frequency, and then just remember the wavelengths increase the other way.